Welcome back to another video.
Progress update. I've got some batteries, so I'm now seeing how long I can run it on batteries and how long they sustain for, how much I have to charge them back up, all that stuff. So that's basically all I've got with this, because it is Chinese New Year, so everything's sort of a bit slowed down. Other than that, I've been getting a few requests on actually how the circuit works here. Let me show you. Alright, so the signal comes in, goes through one op amp. Why do I go through an op amp at the start? Is because at that point, when I come out of here, the op amp starts creating the signal, and so that means all the load and all the burden comes from the op amp, not the signal generator. So once I go through the op amp the first time, I break out. That first breakout is going to be my A phase voltage. Each stage is exactly the same, so I won't go through each one. Okay, and then it comes back out and it goes through another op amp. Alright, then you can see I've got a point here which comes around to a switch. Alright, so it's gonna, those switches I'll just show you on the board. I'll put a little picture down the bottom. That's what they are. Alright, so then if you flick the switch one way, it comes out after this op amp. You flip it, it comes out after this op amp. So you can see it goes through another op amp again. Okay, and in these circuits with the op amps, this here is a variable sort of resistor or potentiometer. Again, on the picture. Now you adjust that, I can get 0 to 180 from each stage. But when I go through the op amps, it flips it to the other side. So I get 360 from doing 2. So that switch gives me lagging or leading. And then it comes out, and I've got a signal adjusted from the A phase. So, and then what happens is I go through, create a second phase. Same deal again. Each of them, you can see I've got potentiometers, and then I come out of them. And then what I do is these ones are trim pots, so I can physically set these. So now to create the power, I use power amplifiers. The same sort of power amplifiers you'll find in audio circuits. So these are Class D power amps. Now these have a separate DC supply. That way I can actually have a battery run my test quite easily. Alright, so we have a DC into the power amp. Then in the speaker input is the signal input. So I'm going to take my signal out of my op amps and put it in the speaker input. So you've got to remember, my signal is just a waveform. So the power amp is just creating my waveform. Alright, before the signal gets in, I have a potentiometer again in the picture. Now those potentiometers act like volume control or amplitude control. So the lower the amplitude, the less step up it has. So that's how I get the voltage changing and the current changing. Alright, so out of the power amp, I have transformer, and now that transformer is what gives me the voltage output. So that steps it out, because this can only go up to the rails of my DC in. So if I've got 24 volts, I'm not going to get more than 24 volts out. From there, I get my isolation as well, but I also get my volts out. So then what I have is I have 3 transformers, and I tie them up I tie them together and create one neutral and create a star output. This right here is a loading resistor. This helps get you your voltage rise when you have a high impedance load, because you remember power amps are designed for speaker outputs and stuff like that, so it's not really designed for this. So this loading resistor, for me, it's about 3K. That's enough for it to be able to push power out. Right, now with the current circuit, it's the same thing again. Potentiometer controls the amplitude. The higher the amplitude, the more current. The lower the amplitude, the less current. Running down, again, power amp. So signal in, signal out, DC in. Simple as that. Then I have a loading resistor. Now, you'll see power amps, you know, they're rated at 4 ohms, 16 ohms, 8 ohms. You pick one that it's rated for, but bear in mind, the more power you pull out, the more chance you're going to get distortion. Distortion in a wave, sort of, depending what you're using it for, may not be appropriate. Okay, so what actually happens is that that loading resistor, is what pulls the current around the amp. Okay, now that's going to be in series with the current transformer. That current transformer pushes current to the other side, and this is my I out. Alright, so that's going to be proportional to this based on the turns. Okay, and then it goes back in. That's it. That's how the circuit works. It is super simple. Maybe it looks a bit complicated, but it really isn't. Things to worry about is probably the heat coming off the amps. The more you can use transformers to adjust the stuff, the less heat comes out of the amps, less power it's got to push to get to where you want. So the whole idea is you don't go buy the smallest amp you can that just works. Overpower your amp, then you can use it down low. Won't get as hot. Alright, if this stuff helps you, hit that subscribe button, hit that like button, and come back for another video.